Hi, hello, and welcome everyone for this last training session of this training camp. In this, I'm going to talk about iShare deep dive. So we'll look at how iShare specifications of the IAM look like, um, how you achieve the flows, and how um, i4Trust data sovereignty and trust aspects, which are based on iShare framework, how do they help you? Let's begin. I'm Rajiv Rajani. I'm the CTO of iSHARE Foundation. We'll be conducting this session, followed by a session by my colleague Francisco, who will explain to us on the data value creation in the marketplace, followed by a session from Stephen, um, who will explain on the iFortrust components and how all of them come together with an example and a deep dive in that example. Okay, let's begin. So let's start with iShare technical deep dive. Um, for who attended my previous session, they already probably saw this role model, but I'm here going to recap this role model a bit, so that as a refresher. So iShare defines this as a role model where you have the data exchange interested parties, which are basically data consumer, data provider, and data owner. These are the parties who are interested in exchange of data, consumer being the one who receives the data, and the provider being the one who provides the data, usually on behalf of a data owner. And of course, in the middle, you see the essential roles which are needed in any for trusted data exchange, and that is in the middle you see iShare Satellite, which acts as a registry of all participants, where participants can discover each other uh, uh, basic metadata about each other and the status if they have agreed to the same terms of use, which covers the legal aspects of the framework. Um, then you have also the identity providers. In iShare, identity providers are only needed for human identities. So when a human data consumer wants to access any data from any portal of the service provider or data provider, of course, it needs to authenticate himself, and it uses an identity provider to do so. An authorization registry, which is another essential role, is basically enables what data owner wants to do. In essence, allow authorization to have for data consumer to have access to data directly at the source, that is the data provider. Um, in authorization registry is basically where it specifies who the subject is and what attributes that subject can access. And additionally, it can also specify the data license, which defines the usage terms or usage policy for that data set for that consumer. And that consumer is legally bound to abide by that data license because it has signed a legal agreement stating so, and for which the status could be checked at iShares Satellite before every transaction if needed. So, okay, this is about role model. What is iShare Satellite? I will explain this a little bit more in detail before we begin on the rest of the part, because sometimes it's a bit confusing. So iShare Satellite is a federated role in iShare, which needs to be uh, it is usually played by an organization within the data space, which is responsible for onboarding participants of that data space. So essentially, Satellite is a tool where the organization would register participants of that data space, and while onboarding, it has certain requirements from that participant needs to fulfill. So it essentially checks that and guides the participant in fulfilling those. So on one hand, on technical side, it has to implement all the technical specifications. On the other hand, they need to procure PKI certificates called eIDAS certificates, uh, and as well as provide organizational data which can prove that that organization is essentially a legal entity. And once all that verification is done, Then they sign terms of use based on iSHARE's framework, um, uh, which is a legal multilateral agreement that they sign into. And once they have fulfilled all this requirement, the participants can be registered by satellite in the network. Um, Satellite is basically distributed based on distributed ledger technology. So it is every satellite is a node on the same ledger, which essentially means that once a satellite register any participants, that participant is accessible on that shared ledger by all the other satellite participants as well, which enables you to have interoperable trust at base level, right? There can be additional requirements at data space level. So if you want to interact with another data space, you might have to also cater to that requirement. But that's more on the advanced interoperability topic on data spaces. Um, um, but here it's basically at base level you are still findable and trustable with each other, because every satellite follows the same process for onboarding all the participants. Um, and of course this is federated, so it's as soon as it is registered, the participant ends up in the distributed ledger. uh, in a data space, each data space should have at least one trust provider, and the trust provider role is the technical component for that is iSHARE satellite in i4Trust, which is completely compliant with iSHARE framework and completely in line with i4Trust principles and building blocks. Okay. Yeah, this is just more details on identity provider role, because these are essential roles in iShare or in any trusted data space. The identity provider, as I say, was is for human identities. Uh, it is essentially described to be based on OpenID Connect standards. If you have an identity provider which is already using OpenID Connect, making it compliant with the iSHARE specifications is much more easier, because the specifications are quite close to OpenID Connect. Well, there are some deviations that we had made, or adjustments or new requirements that we have changed. But overall flow looks like OpenID Connect. There is no change in that. Um, but the changes were necessary in order to make sure that OpenID Connect can be used in B2B and G2G or B2G kind of situations. Um, it was not appropriately addressed in the basic OpenID Connect standard. Uh, of course, as an identity provider, uh, when you want to register in the network as an identity provider, you need to go through a check, which is based on a framework based on EIDAS. So essentially, EIDAS uses this framework also to onboard EID participants or EID providers, basically. And iShare also specifies the same framework to be followed, um, which determines the level of assurance of that organization as an identity provider on one hand. So this is important in order to support different kinds of use cases. So when there are critical um, use cases and you need really high level of assurance, you can select only identity providers which meet that criteria, for example, to support your use case. um, on the other hand, of course, if the data is not critical, you can work with any identity provider that is registered. Um, and of course, they based on the level of assurance, they follow certain practices, best practices, and security standards, ISO standards, and whatnot. But they are all detailed out in the assessment framework. Another essential role is the authorization registry role. Authorization registry role, as it is defined in iShare, uh, is a role which allows the data owners to to either create policies for access for data consumers on one hand, and on other hand, it can be that they use existing information like transaction data or their existing LDAP or policy database that they might have as an internally in the organization, and use that to on the fly create the authorizations that are needed. So iShare only specifies the API for request and response of the authorization. However, the implementation of the AR and the standard used for storing of policies or determining the authorizations that is kept open. So all authorization registry providers can choose their own standards and work with their clients in order to make sure that they can provide this essential service. Example of the request or response more that you would get in when you are asking an AR the question is basically looks like this, where you can define also the fine grained access, which is basically exactly saying that this subject with identified by this identifier have access to these and these attributes and can only do read and write off on those attributes basically at only this particular service provider or data provider, for example. And the usage licenses are defined here. Here is the tag of that license, and what that license means can be found on the website. Um, it can also be so it essentially either gives you permit or deny effect, um, which essentially allows the data provider to make a decision whether the subject should have access to the to particular data set or not, which it is asking for. On the other hand, it can be very coarse grained as well. The support for policies that you can define policies which allow access to everything, irrespective of the attributes that are being asked to the subject, and you don't really care about usage conditions, for example, if the data is not that critical. So these are supported. Uh, to sum it up, or in the trustworthy interaction on any data exchange. So for any data sharing transaction, the first and foremost step is always identification, authentication, and authorization. If you are able to do those, then essentially you are able to share the data or not, depending on the authorization of that subject. And all the kinds of interaction that are supported are basically machine to machine. So two servers can talk to each other. That is, the flows are defined based on OAuth principles and using PKI infrastructure. And they essentially are basically, as you will see in with an example after in a while, how that is achieved. And there is no middleman usually involved in the whole transaction. And the human to machine interaction, where the human uses a browser or an app to interact with the portal to get that access to the data, and it is used using identity provider to identify itself. As I explained, it also facilitates flexible authorizations. You have various kind of authorization possibilities. Essentially, what we are moving into is, instead of role-based access, we are moving into attribute-based access controls, along with usage policy, which is defined by the data license. And also the portable identities. So the way the whole framework is designed is that it allows participants to completely choose their own identity provider, um, as well as authorization registry provider. So there is never a lock-in. It's portable because the specifications allow them to be interoperable, irrespective of when you change the provider behind it. It should still function in the same manner. Um, Essentially, what in all this enables is delegation possibility. It's not only that you can give access to a particular organization or a human, but you can also further delegate that right. So if you have rights to some data and you pass it on to, say, company A, that company A could further pass it on to company B, for example. And in the end, forming a chain of delegation which allows the final entity who actually needs the data to have access to the data directly at the source, because essentially we enable decentralized data sharing. So you don't need to copy your data on every platform, but you can expose the data directly from the source to the right person using this framework. And all of this in essence gives complete control to the customer or the data owner in that sense, because on one hand it can select its own service providers. um, it can define who has access to what exact data elements, uh, and what kind of access. And on top of it, it can also define what the usage conditions are or usage policies on those data set are, which gives the data sovereignty to the data owner, because the receiver of that data is legally bound for abiding that usage policy. Okay, so let's get into the very basics of how IAM specifications work. How, when you want to implement, you should be clear of these basic concepts in order to make sure that you can implement the correct specifications. So first, I will briefly explain to you all these four elements that you see on screen, which are very vital for any IAM setup in your data sharing. The first part is the certificates. So what is a certificate? Let's look at it. A certificate is a digital file which is issued by a certificate authority after performing certain validations. Example of digital certificate which is more commonly known is like the certificate which you use for enabling HTTPS on your website, commonly known as SSL certificate. um, but that is a certificate issued for a particular domain or a server, basically. And it the kind of certificate can range from like free certificates like Let's Encrypt to very extended validation done by the CAs to issue you certificate after done doing a lot of validations. But we are not talking about that certificate when we are talking about this, which is relevant for this iShare and i4Trust IAM components. Here we are specifically referring to digital certificates, which are commonly known as qualified seals, which are equivalent to your hand signature on a paper as a company authority or authorized person to represent a certain organization. Those kind of certificates essentially also stand valid in legal court of law, um, and it is equivalent to an authority of a company signing on a certain document. But when you use this digital certificate to digitally sign data, it has similar cadence as paper data on the paper, which is signed by that same authority, right? Um, but what is a certificate file? Well, it essentially proves the ownership of that file, um, because it has been the information that is stored in that file is validated by a well-known authority that's normally called certificate authority, who performs a lot of validations before issuing you those certificates. And it can be used for signing or encrypting information, right? Now that certificate consists of usually two parts. When you buy a certificate, you are usually you have two parts of that certificate. One is the public part and one is the private part. Private part is like your secret or your password, but in a file format which is very cryptic, which you need to keep secure all the time. because that proves ownership of the public key. Basically, public key is, or public part of the certificate is, basically where your organization information is registered by the CA, and that you can publicly share everywhere, so that they can see who to whom this certificate belongs to, and what kind of certificate it is, and other details about it. Uh, so this is vital for how iShare uses PKI certificates, because we use these certificates, or the specifications are such designed such that they use the certificates for verification, signing, and also it can be used for encryption purposes. Uh, but yeah, as far as all the IAM transactions are concerned, it's mainly about signing the tokens using this certificate that is issued to you, and which allows you to present a token which is signed by that certificate to another party, so that that party can validate who you are, essentially, and trust you, basically. um, in iShare, we refer to public part of the certificate as XYC value. It's a chain of the certificate. Basically, certificate is issued by a CA to an intermediary, and intermediary in turn issues you the organization certificate, usually. um, and the whole, that is called a chain, because it includes basically three certificates. The public part of your organization, the public part of your intermediary who issued you the certificate, and the public part of the certificate authority who issued intermediary the certificate in first place. And together that forms the XYC part of the value when we talk in iShare terms. um, P12 file, or it's commonly known as PKCS12 file, it usually contains both private key and public key, and it is usually an encrypted file, so it is password locked. So even though someone has file, if they don't have password, it cannot they cannot find the private key out of it. But essentially, the private key is what enables you to sign any data set. And there is on this slide explain, so there is some data or file that you want, that other party wants, you want to send to another party, and you want to make sure that the other party receives the data as is, in the right format, without any third party in between, who has modified it, for example. uh, this is usually to do with the cybersecurity, when a man in the middle attack can actually incept your data and modify that data, and present the modified data to the receiver. Then the receiver has no way to know about it. How do you make sure that receiver knows exactly what you have sent, and it can trust that information? So there are two ways. One is signing the data. uh, so you sign the data, which essentially means that it's like a, as I explained, a paper with printed information, and you as an authority sign it. Now if you pass the paper, uh, uh, open paper to via courier, then courier of course can read it, but he cannot modify it, because modification would essentially mean there should be another signature. In digital world, it sort of works in a similar manner. So when you have a data or a file and you have signed it with your private key, if any change is attempted on that data or file, the signature becomes invalid automatically. So it is digitally verifiable that data was tampered with, and it will not pass the signature test on the receiver side. Um, but when it is not changed, of course, the receiver can validate if it was signed, the data which is presented was actually indeed what was signed on. And that gives the receiver the trust that it can trust on that information that it has received, and it is validated from the signed authority or signed person. right? Um, Other aspect is, of course, which is not mentioned here, is encryption. If you don't want people to read your data, what do you do? You usually use a secure envelope to send critical information on the paper. Um, and when that envelope is being tampered with, the receiver would know that it was tampered, and it can no longer trust it, but also inform that, okay, this information potentially has been leaked. Encryption on digital world also acts similar to that, so that the party in between cannot read it, and of course cannot modify it. If they modify it, everything becomes invalid and cannot be verified digitally on the receiving end. Okay. Then we move on to the next important element on which we use extensively in all of our specifications, is called JSON Web Tokens, or JOTs, or JWT, however you want to call it. JSON Web Token are nothing but basic C4 encoded JSON objects, and in essence they can be made from three different parts. Basic JWT only consists header and payload. Uh, and when you sign a JWT, it is called JWS, which is basically JSON Web Token signed, uh, and it includes an additional element called signature. So in any JWT, you will have an header aspect which defines the details about what algorithm and what type of JWT it is, or what type of object it is, basically. So if it is signed using a certain algorithm, it will include algorithm. It can include certificates in XYZ value, and some other additional metadata information about the token itself. The second part of that JWT is the payload, which is where all your data is actually. So when you want to share certain data, you put that data in the payload. It can include the claims, like if it is an identity token that you want to share with other party, then it includes all the identity information from you, like your name of the organization, the ID, and other aspects about your organization that you want to share. Uh, and it can include any kind of data. So if you are exchanging any data, uh, say for example container ETA, and you want to include that as a signed thing, then you can include that information in the payload. The third part is the signature. So once you have the header and the payload, you that is your whole data set which you need to sign, um, and you use the private key to do that, and the resulting signature is added as the third part in the JWT. So you can see that the output becomes like this, which is also can be seen in three different parts once a JWT is created after the signing. The output will contain encoded header, followed by encoded payload, followed by encoded signature, and the receiver knows how to decode and verify this. There are a lot of libraries available which can also help you to do that. And when you combine all of these three elements by dot, you essentially have your complete JWT. If any of the element is missing in a JWT, then JWT is not verifiable, so it will not become a valid JWT. So you need to send the whole set when you are sending to someone. So in iShare, we use extensively JWT, but we call them as client assertions, specifically when you are sending that as an identity token to another party when you are authenticating yourself, or identifying and authenticating yourself. So in iShare, we have specified what headers you need to specify. So as you can see on the screen, the XYZ value, as I mentioned earlier, that's your public certificate chain that you need to include in the header part. In the payload, we have defined attributes that you need to define as minimum attributes when you are sending this client assertion. You can add additional information, but these are the minimum required set of attributes that you need to send. And it essentially contains issuer, which is your identifier basically, uh, uh, the subject uh, uh, to whom this identity token belongs to, basically. So in client assertion, it's always the case that issuer and subject are the same. JTI is nothing but an JWT identifier token. It's a random string. There is no specific format defined for it, so you can use any format for it, but it has to be a random string that you can use. Then the time of this time elements of this particular token, because this client assertion is very key for your identity and authentication. iSHARE defines that these tokens should be valid only for 30 seconds, not less, not more. This is very specific in this case. So your issue date and not before usually are the same timestamps, whereas expiry should be always plus 30 seconds of your issue date. And you should generate this client assertion when you want to use it. So you generate it for 30 seconds and then send it over, so that within 30 seconds the receiver can validate it, because after that it becomes invalid automatically. And the audience is the identifier of the party to whom you are sending this token to. So the this is also essential for the receiver to know if this token was actually sent to that intended for that organization or not. If it was not intended for that organization, it should reject it, because then somebody in between has gotten access to your client assertion, and it is trying to impersonate you, basically. That could be the case. So it should, from security perspective, it is not recommended that you as a receiver should accept tokens whose audience do not match your identity. Yes. uh, and of course, as I mentioned, signing, so you had the header and the payload, and then you need to sign to make it a complete JWT. So when you sign it, then it becomes a complete JWT, which is called as client assertion in iShare, which you can share with the other party to get access to the services from that party. And that leads to the final part, that is uh, the access token that you receive. So in in iShare terms, specifically when two servers are talking, based on open or 2.0 specification, the service provider or data provider always exposes a token endpoint on which the consumer can send the request with the client assertion to get the token. Remember, this is just for authentication, identification and authentication. Having gotten a token back from service provider or data provider does not necessarily entitle any authorization on any data set, because the client assertion is such that it is only an identity token, and the access token is basically returned based on the identity token, which is validated by the data provider, right? So in this screen you can see that ABC Trucking, an example company, generates the client assertion, sends the token to the token endpoint on the service provider warehouse 13. Warehouse 13 validates it, and if it finds everything is okay, then it can issue a token back uh, uh, to ABC Trucking, which it can use for further requests that are sent to warehouse 13. The token endpoint, as it is defined in iShare, is specific. It has the grant type, that is client credentials. The scope has to be iShare, so that the receiving party knows that the transaction should happen within the framework of iShare. The client ID, basically who is requesting this token endpoint. The client assertion type defines this is a static string that we expect you to just uh, paste as is. Um, it's basically saying that it is the client assertion which is of and the token should be written, which is bearer type. um, and of course the last but item is the client assertion. uh, which is the JWT we just saw how it is formed. And as I said, once validation is done, the service provider will return with a token. Now remember here, important, this is an access token, which is different from client assertion that you sent, right? So this is a token for you, it is just a random string. Using this token, you can invoke any data service that is exposed by this data provider. Now this access token expires in this much time. Basically, this token is on the screen 3600 essentially means 1 hour. It's an expiry time in seconds, basically. So this provider issues you a token which is valid for 1 hour. So you can reuse this token for 1 hour to interact with this service provider as a consumer, right? And the type is bearer. So anyone who bears this token can request the data services, basically. So let's take a good look at how all of this can be uh, how an access to data is achieved with all the elements of iShare role model using a fictional use case, which makes it a bit more easier for everyone to be clear on and understand it. So the case is basically that there is a trucking company which has to pick up a container for its customer called Banana and Company, which has requested a consignment from abroad, and the consignment arrives at a warehouse known as Warehouse 13. Uh, but in typical scenario, what would happen is in today's world that whenever ABC Trucking has to know when it can go to the warehouse to pick up the container because it doesn't know the ETA, it has to call Banana and Company. Banana and Company would call warehouse to check when the container is expected and relay that information back to transporter. Now imagine if there are more parties in between, which is practically usually the case. There are freight forwarders and there are subcontractors involved as well. Um, uh, then the communication becomes very inefficient because there's so many hops for that information, and by the time it reaches the desired party, it actually is most probably outdated information. Let's see how with this example how sharing of access to the data and giving authorization to the data helps this organization. So here is the role model of or mapping of the organizations to the role model. The ABC Trucking Company will become the service consumer. Warehouse 13 becomes the service provider. The Banana Company is entitled party, is basically the data owner. An authorization registry called as Ask Me Anything authorization registry. Now, in iShare, we also have, as I explained to you, we rely on PKI certificates that are issued, and these are issued by certificate authorities which are there in market. So you can buy your certificates from DigiCert, FIWARE, and other providers similar to that, Secure Trust and others. Um, but of course, that essentially means that you will end up supporting or accepting any kind of certificate from any of these CAs, which is what not the whole purpose of this framework. So we have um a restricted set of kind of certificates that we expect accept to be in order to maintain certain level of assurances in the network and the trust level. And that list is published or that list is maintained also via the satellites. And these satellites, via this satellite, you can always download the latest trusted list. But because this list will list all the CAs, basically the certificate authorities, and you can expect that this list doesn't updated like every minute or so. But in fact, this list is maintained or updated very occasionally when a new CA is there or an existing CA has to be revoked or there is a change in the CA structure or whatever. Only in those situations you will find that this list has changed. But anyways, it is recommended that the parties can get this trusted list and cache it in their own systems, so that they don't need to call satellite every time they need to validate any tokens. And this depending on your company's risk policies, you can cache it for different length of periods. Basically, the list, it can be from like 4 hours to a week or even a month, for example, but that is up to you, right? So this is beforehand. This is something not related to any transaction, but this is an important reminder that you should have already cached the list. If not, of course, you can always call the endpoint directly, but it is highly recommended that you cache this list locally. Okay, let's begin on the machine-to-machine use case and see how the whole flow looks like. So before the actual transaction happens, the first thing it is assumed in this case is the entitled party, Banana and Company, registers the authorization for ABC trucking at its authorization registry. That is, Ask Me Anything. It essentially defines a policy which says ABC trucking is the subject, and it has access to the containers which are identified by X, Y, or Z, and they can access certain attributes from those containers. And this is registered in the authorization register. Now, uh, the Banana and Company informs directly to the trucking company that it has already registered the authorizations for that, so it can directly go to the warehouse 13 to get the required data, and it doesn't need to contact back Banana and Company for getting that data, right? So with that information, ABC truckings, now is the actual transaction happening. So the first thing is that essentially here is that ABC trucking wants to know the ETA information of the container that it wants to pick up from the warehouse 13. So in order to do that, first it what it does is it connects to the token endpoint by saying by sending a client assertion saying that I am ABC trucking company. Here is my identity token which is signed. Please validate and issue me an access token, right? So the request is sent. Now the warehouse 13 checks the certificate that signed the JWT. It validates the JWT. Now it wants to know. So it is part of the process that it wants to know that if ABC trucking is also known in the satellite, because this is needed to know if ABC trucking company will also legally abide by the terms of use of the framework under which the data is shared. So this is done to make sure that ABC trucking gets access to the right data, but it also follows the usage policy that is defined by the data owner under that authorization, right? So for that purpose, it needs to check with the satellite what is the status of this organization in the participant register. So but as you can see that warehouse 13 is also there is a server from warehouse 13 which also connects to the satellite backend or API. So it needs to also do the same thing, that it needs to connect, send a client assertion to connect to the token endpoint to get an access token in first place. So that is done, and once the token is issued, then it can get uh, the information about ABC trucking by querying on specific parties endpoint by sending uh, the ID of the ABC trucking company to the satellite, and in response, the satellite gives back all the details that it has about ABC Trucking Company. It includes the status of ABC Trucking Company, but also additional metadata about that, which is registered with the satellite, right? So once all this information is there, and because it already validated the certificate and the JWT, and it sees that ABC Trucking is in active status, registered with the satellite, it can now trust enough that this organization can be issued token, and it can request for the data. So it sends the access token to ABC Trucking Company. Using that token, the ABC Trucking Company sends a request. Okay, say, can I get access to data regarding container Z? Um, and in this case, it is already informing where the authorizations are stored. So this is one option. The other option is that service provider or data provider already knows, based on the owner of the data, where the owner of the data stores the authorizations. Or there is another option. If it doesn't know where the authorizations are stored, then but if it knows who the owner of the data set is, which it should know because of the nature of the business, um, then it can also get that information from the satellite by asking the satellite where does the data owner, in this case Banana and Company, stores its authorizations for its consumers. Uh, but in this case, let's just assume that ABC Trucking Company, along with the request to the data, sends where the authorizations can be found for it, right? So here you can see the request is the service provider slash service. So it is basically um, uh, arbitrary. It's up to the service provider which service it is to be exposed, and which service is being requested. But in this case, the service is specifically for data regarding the container C. Now, the next step um, is, before it wants to, so because it sent identifier of the, in this step, the identifier of the authorization registry. Service provider, of course, does not know the URL of that authorization registry. So what it does is goes back to the satellite. So this is the connect token endpoint to get the access token, and it asks for details of that authorization registry, sending the identifier. So in response, it gets all the details about this authorization registry, including the URLs where it can ask for the authorizations. So it is in iSHARE called delegation endpoint. So service provider will get the details of the delegation endpoint from the satellite, and then it can connect to the authorization registry token endpoint, ask for a token. The same process follows at authorization registry. It does check the JWT and checks the certificate. Now it also wants to check who is warehouse 13, and whether it is a known participant in the iShare framework or in this network, in the data space. So the authorization registry sends the request to get all the details of this participant from satellite. It gets back the details of the satellite. Then it can issue a token to the provider. Using that token, then on the delegation endpoint, the question is asked whether ABC Trucking, who is the subject, is allowed to access to data XYZ of the container Z. And it also includes in the question who the issuer is of that policy. Basically, it's Banana and Company, because the provider knows that this container belongs to Banana and Company. It can include that information when it is asking the authorization registry. Now, because if you remember in the very pre-step, the Banana and Company already registered the policy with authorization registry. It indeed finds that yes, ABC Trucking has access to the data of container Z on behalf of Banana and Company. So in response, it says yes, it is permitted, and of course, it's also a signed JWT which is received. So it's a token. So response is also a signed token. So warehouse 13 then checks and validates the token and the signature in it and everything. And once it has established that it is all proper, then it can send the container data to ABC trucking company, which was in the original request, right? So this is how the whole machine to machine flow looks like when you implement the components using iShare framework. uh, these steps establish the trust, and also the possibility for parties who are not known to each other, they can interact with using this model, because the trust is established via the trust anchor in iShare satellite, which can be used for validating uh, whether the organization is known within the data space or not. It is, sorry, it is important to note that sending that query to satellite is also optional depending on your risk appetite as a provider. So if you are able to establish who the consumer is, and if it is a known consumer to you for some reason because of existing business that you contracts you have with them, or if the data being requested is not that critical and you don't bother too much about it, you may want to skip check on the satellite, but that's completely up to you, and that is subject to the use case and the business case. But ideally it is recommended that you always check in order to make sure that you are always legally covered, because when uh, the participant is revoked for whatever reason and you still serve the participant with the data, then there is nothing you can do about the data that has been shared, right? Now extending this use case, because we saw this how two machines can interact and exchange data, I will just extend this case, the because the flow that you saw was based on OAuth 2.0, and now we will extend this case with the identity provider, so we'll include a human element in it. But as you know, probably OpenID Connect is also based on OAuth 2.0, and you will see there are a lot of similarities. The only aspect is that there is an additional identity provider related flow. In the remaining, most of the process remains the same. So let's just quickly go through it. Um, so here the participant is more or less the same. The banana and company is the entitled party or data owner. Warehouse 13 is the data provider. Now driver X is a driver of the ABC trucking company who was the service consumer. So now this driver X acts as a service consumer. And there is of course the authorization registry. Here it's the name registry X. Essentially, this registry supports both machine to machine policies and human to machine policies. We'll see in a bit. And an identity provider, which will provide the identity to the driver X. So uh, here again, the pre-steps, assuming that the policies are registered before the transaction actually happens. So Banana and Company first delegates the access rights to ABC Trucking, saying that it has access to its container data. Next, now ABC Trucking Company also authorizes or register authorization for its driver X, that it can act on behalf of the company ABC Trucking Company, and where it can represent that company when it is picking up container or dealing with containers, for example, right? So these are two authorizations that are stored now. Here, it is assumed that driver X is either using a browser or a mobile app, and it is connecting to a portal, or if it is the app from the warehouse. Uh, to here in this case, it's like driver is asking access to the warehouse premises, uh, and it needs to identify itself in order to open the access gate from the warehouse premises, right? So it directly checks on this particular service from the warehouse 13. But warehouse 13 sees, okay, there is a request, but it doesn't know who the identity is. So first it sends back saying, okay, first, can you identify yourself who you are? And it gives an option list of options of identity providers which it can use, right? So driver X, because it knows secure logistics, which is its identity provider, it sees it in the list and it says, okay, I will identify myself using secure logistics. This is very similar to how you see today in a lot of web portals, where you can say you will sign in with Google, Facebook, or Apple, for example. It's a similar flow, which is basically OpenID Connect based. So driver X says, I will log in myself or identify myself using secure logistics. So warehouse 13 then redirects the driver to secure logistics. So it's the browser which is redirected. And as you know, in OpenID Connect, it's the authorized endpoint where the request is sent with all the details. Now, along with the details, it also sends the client assertion from itself. So secure logistics, because important aspect is that in iShare we do not require identity providers to pre-register service providers that it can work with, because they can always validate which provider is trying to connect to them and establish the trust using satellite. So registration is not required. Um, in OpenID Connect, it is very close to the concept called dynamic discovery, which is defined in the standard. However, the difference is that in the standard, it is mentioned that upon dynamic discovery, you need to register that service provider. In this case, it's dynamic discovery and never need to register that service provider, because you always check at the satellite if the provider is known in the network and can be trusted. So with the token, now this is the same process. The JWT is validated, the certificate is validated. It also wants to check if warehouse 13 is the known participant in the data space. So it first connects to the satellite with the token to get the token. Once it gets the token, it also wants to see if it asks for the details of that are known to the satellite for this participant, warehouse 13. In return, it gets all the details of the warehouse 13. If everything checks out, it can validate, okay, yes, this is indeed a genuine request from warehouse 13 to validate a certain user. Now, here is the difference in the OpenID Connect terms, because that authorized endpoint, even though it is, let me go back there. Even though this arrow shows directly from warehouse 13 to secure logistics, it is actually a redirect via the browser of driver X in reality. So it's an indirect flow in that sense. And in response to that, once everything is validated, secure logistics will present a login screen to the driver X asking for credentials, because it also needs to know who is logging in. Driver X logs in with his credentials. It will also present two-factor authentication depending on the request from the provider. So provider can, along the request, send what level of assurance is needed from this identity. So accordingly, the identity provider will present the login options uh, to the driver, and driver will have to follow those option to meet the minimum level of assurance of that identity needed, right? So login is done. Now secure logistics knows exactly who it is. And again, this is an indirect flow. It is sent via the browser of the driver back to the service provider. There is it is sent. It sends a code, secret code, uh, and using that code in the next step. Now this is direct connection. The warehouse 13 connects directly to the backend of secure logistics. The token endpoint, it sends the code to get retrieve the token. And in return, because it is known code and it comes from uh, the server which requested initially the whole request. Uh, After all the validation done as per the standard, secure logistics will send an access token to warehouse 30. Now, using that token, warehouse 13 can request all the information of this user using the user info endpoint. So it gets exactly who the user is, which organization it represents, basically, and additional attributes that it might require for it, right? So, of course, in response, all the details are sent, like driver is X, is from ABC Trucking, and additional information as was requested by service provider. Now, service provider needs to know, okay, it has established the identity, but it doesn't know whether this identity should be allowed access in the warehouse or not, because warehouse access is secured by, okay, when there are containers to be picked up and they belong to certain organization, if an representative from that organization comes in, then they are allowed. So that is how they determine the authorization. But it sees that it has come to pick container Z, uh, but it is not the owner of it. So it needs to know if it is delegated the rights for it. So it checks the authorization registry. Again, the same flow. This is now machine to machine flow again. Warehouse 13 sends a connect token request to authorization registry. Authorization registry does the validation as explained earlier, gets the details from the satellite, sends back the access token. Now it is asking delegation at the delegation endpoint of authorization registry. Is driver X authorized to get access to container of banana and company? Um, because authorization registry has two policies registered with it. First, from banana and company authorizing ABC trucking, and ABC trucking authorizing driver X for everything to do with ABC trucking. There is a clear link of delegation in that sense. So authorization registry responds back saying yes, there are two policies, and together they determine the right authorization for this driver. Uh, it sends the such a token back, and the warehouse validates this token. And after the validation and seeing that it is permitted, it allows access to driver X on the premises of warehouse. So this is how the machine human to machine flow also looks like. As you can see, there are a lot of elements from machine to machine flow also included in this. But these are the two basic interaction models. There are different ways in which similar result can be achieved. This is one way of doing it. So when you are working on your use case and you are defining your solution, we can together work on what would be the efficient best way to achieve your use case depending on the choices. And this was it for my iShare technical deep dive. Further useful information and resources on learning of all of this can be found on the links on the screen. So these presentations and the sessions are recorded and they will be made available to you. You can find them via our website, right? Then I will summarize this all. How does this all fit in the i4Trust? Because what I explained was mainly iShare technical aspects, uh, and the non-technical aspects I already covered on the Monday session. Uh, but now you see on the screen that i4Trust presents to you the whole building blocks, or it is a ready boilerplate for creating on data spaces. And you can see the iShare logo also on the sovereignty and trust aspects. So essentially, the framework is covering these elements or these building blocks in the 12 building blocks, and FIWARE provides already implemented specifications or in their open source components, which allow you to achieve the same results. So you don't need to develop everything by yourself, but you can just use the open source components from FIWARE to comply with these building block, vertical data sovereignty and trust, and you can achieve the same results, right? Um, I'll just briefly recap on how what the i4Trust data space role model looks like. The trust provider, which acts as the trust anchor in the data space, which allows participants to validate whether the other participant are also part of data space and can trust each other before sharing the data. The middle layer is the roles which are interested in the actual data exchange, consumer, provider, and the owner. And on the bottom, you see the essential services uh, of data space, like identity provider for providing human identifications, authorizations provider for playing the role of authorization registry, and marketplace, which will be explained in the next session. But this is essentially for data value creation, uh, so that data provider or data owner can publish data sets on the marketplace, which consumers can look for or search in the marketplace if they are looking for specific data sets, and can directly procure access to it. Um, as I mentioned, open source components for all these roles are available. They are provided by FIWARE, compliant with iSHARE specifications where needed, and they are ready for your use to create your data space today. I will skip through these slides. Yes, and that is it from my side. And with this, now I will hand over to my colleague Francisco, who will talk about the marketplace and the data value creation aspects in the data spaces. Francisco. Host, can you bring Francisco on stage? Yeah. Okay.
Okay, now I'm here.
Yes, I will stop presenting
Okay,
and I will leave the floor for you.
let me share my screen.
Yes.
Well, first of all, thank you for attending to this session today. I need to say sorry because my voice is a little bit broken today. But anyway, let's try to do this presentation. Well, my name is Francisco de la Vega. I am CTO and co-founder of FICODES. FICODES is a company that is member of the FIWARE Foundation, and we are basically taking care of two different components. On the one hand, we are taking care of the WarCloud, which is a component that is used for dashboard creation. And on the other hand, we are taking care of the business API ecosystem software, which is the one that is used in order to create this i4Trust marketplace. Okay, so this is the agenda that we are going to follow. I'm going to start with an introduction to the business API ecosystem software itself. Then I will show you the basic concepts that are on behind of the business API ecosystem, so you can know how to use this software. And in a second part of the presentation, I will show you the how we are using the business API ecosystem in order to create the i4Trust marketplace. Well, I'm starting with the business API ecosystem. The business API ecosystem generic enabler is a software that allows you to create different kind of digital marketplaces for the monetization of any kind of digital asset. The idea of this software is that it's providing you the tool to manage the life cycle of the different product offers from the creation of the product to the monetization, the billing, the ordering, the payment, and finally the revenue sharing in case there are multiple stakeholders involved in a particular offer. This business API ecosystem is fully integrated with Identity Management Framework, or the IAM framework that was presented on last Tuesday. And one very interesting point of this software is that it is relying on the TM Forum business APIs. These APIs are providing some standard for the management of products, for the management of order, for the management of usage, billing, and a lot of things. So all the functionality that is exposed by the business API ecosystem is also exposed via API through these TM Forum open APIs. Okay, so which are the main features of the business API ecosystem software? On the one hand, as I said, this is something that is intended so you can create your own marketplaces. So it's highly customizable. It allows you to provide your own branding. You can play with the theme, change the colors, whatever you want in the look and feel. And then it is integrating with multiple identity providers. It is integrated on the one hand with the FIWARE Keyrock, but it is also integrated with Keycloak by Red Hat. And if your use case is quite simple and you don't want to waste your time with user roles and these kind of things, it is also integrated with GitHub. So you can use GitHub accounts in order to log in the system. Well, as I mentioned, the business API ecosystem is intended for the monetization of any kind of digital asset. But how is this done in practice? The idea is that the core software of the business API ecosystem, the one that is provided if you download the generic enabler, is dealing with those functionalities that are common to any kind of product, which is product definition, offering definition, monetization, ordering, usage management, etc. And those functionalities that are specific to the kind of digital asset that you want to monetize are implemented in the means of extensions or in the means of plugins that can be plug and play into the business API ecosystem. So the business API ecosystem is defining a set of handlers that are called during the life cycle of the product and the offer, and you can implement those handlers in order to make these different actions. For example, if you are going to create a product which is where you want to sell the access to an API, probably during the handler on post-product creation, you will validate whether the user creating the product has actual access or is the owner of the API he's trying to sell. If, on the other hand, you are trying to offer something like an Android application, for example, that handler is going to check whether the file you are uploading is a real Android API key, etc. Not only for validation, but also for service activation. When you buy a service or something that is secure with a FIWARE framework using Keyrock, etc., probably the handler that you are implemented is going to grant some kind of role in Keyrock or is going to create some policy in the Authorization Registry, etc. Okay, so this is the idea. The business ecosystem has the common functionality, and then for your specific asset type, you can create an extension that can be installed in the business API ecosystem so you can monetize any kind of digital asset you want to monetize. Regarding the offers and regarding the price models, the business API ecosystem supports rich price models made of 3 basic paid models and 2 free models. Regarding the free models, you can create the typical free offer, which means that you have to buy the offer, you have to accept the terms and conditions, etc. And when you go through the buying process, you get the asset. Or the business app ecosystem also supports you to create what are called open offers, which are offers whose assets can be downloaded without the need of acquiring, which is quite useful if you want to add some kind of open data or something like that into your marketplace for whatever reason. Not only for open data, you can upload any kind of file, specify that your offer is open, and any user in the system, even without the need of logging in, are going to be able to download it. When we start talking about the paid models, the business API ecosystem supports 3 basic models, which are the one-time payment, you pay, you get the resource, the subscriptions or the recurring payment, which means you are going to pay a fixed fee every month, every week, every year, etc. Or you can also define models using pay-per-use, which is basically you are going to be charged based on the usage the customer is making of the specific asset. The interesting point is that these three basic models can be combined and you can use other advanced stuff that let you create some richer model. For example, it is possible to define a pay-per-use model where you specify an initial fee. So the user buys the offer, pays the initial fee, and the rest of the time he's going to be charged on usage basis. Or you can do something more dynamic. For example, it is possible to define some pay-per-use service and specify that if the user makes more than 10,000 calls during a given period of time, then the user is going to get a 2% of discount. Fees are also supported. Could be fees, could be discounts. Okay, so in addition to this, the business API ecosystem is dealing with the terms of the service. Basically, it allows you to provide terms and conditions when you are defining the offer. There are different ways of providing these terms and conditions. If you are working with data, there is a couple of data-specific licenses that you can just select them from a checkbox. If you want to write your own terms and conditions, there is some wizard you can use in order to specify these terms and conditions. And if nothing of this is okay for your terms and conditions, it is also possible to provide them as a free text. Basically, you can just write them. In addition to this, the business API ecosystem allows provider to specify the SLAs the service is expected to be satisfying. Okay, and the final feature that is coming with the business API ecosystem is the support for the revenue sharing models. These revenue sharing models allows providers to specify how the incomes generated by an offer or a set of offers must be distributed among different stakeholders of the business API ecosystem, meaning that the incomes generated by one single offer can be distributed among multiple providers. The idea with these revenue sharing models, in these revenue sharing models, there are three things that you have to provide when you create a revenue sharing model. You have to provide which is the percentage that is going to be given to the owner of the offer, which percentage is going to be given to each of the stakeholders, and there is something which is fixed, which is what it is called the platform percentage. The platform percentage is something that is configured not by the owner of the offer, but by the owner of the marketplace instance itself. And it's something that is there in order to enable those business models for the owners of the marketplace where they want to receive some percentage of all the transactions that go through the marketplace instance. Take into account that this platform percentage may be 0. So if your business model is different to this one, you can let it as 0 and it's perfectly going to work. But if your business model includes charging, I don't know, 1% of each of the transactions that are going to be managed through the marketplace, this is something that can be done with this platform percentage parameter. Okay, so this is basically the main functionalities that we have in the business API ecosystem. So now we can move to the main concept that we are handling here within the business API ecosystem. The most important thing in order to create your stuff is the catalog elements. Those catalog elements are taken directly from the TM Forum catalog management APIs, and there are different kind of catalog elements. On the one hand, we have those catalog elements that are used in order to classify products, which are basically two. We have categories. The categories are created by a system administrator, so all the providers on a marketplace instance are going to have available the same categories. And then when a provider is going to create an offer, they can choose which categories are okay for their offer. So they categorize the offer, making it more easy to be discovered by potential customers. On the other hand, we have catalogs. The difference is that catalogs are created by the provider itself. So the providers can create catalogs in order to group their own offers. It is also possible to search by catalog. And the interesting point is that you can combine the two of them. So you can search by catalog and by category. This way, it's more easy to discover the different offers that you have in your marketplace instance. Okay, in addition to the categorization, we have all the catalog elements intended for creating a product, which are, on the one hand, the asset, which is the real digital product that is registered in the system. So we are talking about the API endpoint. We are talking about the data. We are talking about the file, etc. That is going to be the asset. And then we have our product specification, which is the definition of all the product-related information. That's it. The description, the product characteristics, any attachment or documentation you want to add, that's it. All the information that is related just to the product. Then we have the product offer, which on the other hand, it has the definition of all the business-related information. That's it. The catalog, the categories, the product specification that is linked in the offer, which is the license, which is the service level agreement, of course, which is the price model, and which is the revenue sharing model. Okay. With that, you have most of the concepts that are needed in order to create something in the business API ecosystem. But as I mentioned before, the business API ecosystem is able to support pay-per-use models. In order to fit this usage that is needed in order to fit the pay-per-use model, the business API ecosystem in general, the TM Forum Usage Management API is defining two different types of objects in order to manage usage. On the one hand, we have usage specification, which is basically the definition of a kind of usage. It contains which are the units and which are the metrics that are going to be used in order to monitor a specific service. And on the other hand, we have the usage document themselves, which are linked to a usage specification and includes the actual usage that has been made of a specific asset. In addition to this, if the usage that is specified in this usage document has been already charged to the customer, this usage document also incorporates the partial amount that has been charged to the customer regarding the usage incorporated in this document. Okay. And finally, the final models and the final concepts that we will need to manage are those ones regarding the revenue sharing. Well, regarding the revenue sharing, we have the revenue sharing model, as I have said before, which is the object that establishes how the income generated not by a single offer, but a set of offers, because it is possible to have multiple offerings using the same revenue sharing model, has to be distributed among the different stakeholders involved giving that service. So it basically includes, as I said previously, the platform percentage that may or may not be zero, the provider percentage, and the stakeholders percentage. In addition to this, the revenue sharing system is also managing the transactions, which is the payment that has been made by a customer linked to a particular revenue sharing model. Basically, every charge that the customer is made. And finally, we have the revenue sharing reports, which is the result of applying a particular revenue sharing model to all its transactions. And it includes the amount that needs to be paid to the different stakeholders and in order to execute the payment. Okay, so at this stage, we know which is the business API ecosystem software, but which is the i4Trust Marketplace. The i4Trust Marketplace is a version of the business API ecosystem software that we have customized in order to provide the functionality that is needed in the context of the i4Trust project. So the first thing that we have done in the i4Trust project is integrating the business API ecosystem with the iSHARE framework that has been presented by Rajiv in his previous presentation. So the idea here is that we are going to have a marketplace that is offered to the different participant organizations in the data space. This marketplace is able to be linked to multiple identity providers thanks to this protocol that has been described previously, in a way that the different providers and the different customers of the different participant organizations are going to be able to sign into the marketplace using their own identity provider, the identity provider of their organization. The idea here is that each data provider organization or each participant in the data space is going to own their own FIWARE infrastructure, which includes their own identity provider, their own proxy, and their own context broker, or any portal or any other FIWARE component on any other software you may develop. Then we are going to use the Json Web Token from iSHARE in order to authenticate the marketplace in the different IDPs. So you can trust the marketplace before sharing your user's data to the marketplace. In practice, how is this achieved? We are going to have the marketplace, we are going to have the different participants in the data space, which could be these ones. We are going to have an iSHARE satellite as a trust provider, and our user from this participant organization is going to log into the marketplace, who is going to redirect the user to their own identity provider using the mechanisms that Rajiv has presented before, which if you want to see them in more detail, the process would be as follows. The user is going to access the portal of the marketplace, is going to click on the login button, he is going to be presented the list of identity providers, and he is going to select the identity provider of their company. Once the user has selected his own identity provider, the marketplace is going to build its iSHARE Json Web Token, signing with a certificate that has been provided using the EORA ID that has been given to the marketplace, etc. And is going to submit this Json Web Token to the identity provider in order to authenticate itself. This IDP is going to receive this marketplace Json Web Token, is going to validate it, and is going to decode it. Once he has decoded the marketplace, then the selected IDP is going to build their own Json Web Token in order to validate the marketplace as a valid participant in the iSHARE satellite component. Once the IDP has validated that the marketplace is a valid participant on the data space, so is authorized to use the IDP as a login endpoint and read user data and these kind of things, the IDP is going to return to the marketplace the login endpoints. So the login endpoint is basically the URL of the login page of the identity provider. So the marketplace is going to redirect the user browser to the login endpoint, and now the user can authenticate itself with the username and their password in their own identity provider. Once we are in this step, the rest of the flow is quite similar to the one in OpenID Connect. What is going to happen after the user logs in the IDP is the IDP is going to return an authorization code to the marketplace, and the marketplace is going to exchange this authorization code and their credentials, which is basically the token generated in the first step, in exchange for an access token and an ID token that can be used in order to access different services or get user information, basically. Okay, so with that, we have the business API ecosystem integrated with all the iSHARE stuff. We may have multiple data space participants and multiple organizations, but probably we will want to sell something in the marketplace. In order to start monetizing things in this marketplace, what has been developed is an extension. It has been a plugin intended for the monetization of data offered through a context broker in the different organization. So this new plugin has been developed that allows you to offer your data in your context broker. In order to do that, it allows you to provide some metadata, basically, that is going to represent the policy that is going to be finally created and applied to the different customers. So you have to provide which is the URL of your context broker, which are the entity or entities that are going to be offered, and then which attribute of that entity are going to be able to be retrieved, which attribute of that entities are able to be modified with post, which attribute are going to be able to modify with patch, and which attribute are going to be able to be deleted with a delete request. And also it is possible to provide which is going to be the duration of the policy that is going to be created. So what is going to happen when you create a new product using this extension? When you create a new product, first of all, the plugin is going to validate all the information that you have provided, whether it is correct or not, and then is going to pick all this meta information that has been provided by the asset and is going to create a couple of characteristics within the product specification. So all this information is going to be displayed in the portal of the marketplace, and you see, and you basically you know what you are buying. Okay. But the interesting point is what happens when the offer is acquired by a member of an organization participating in the data space. When this offer is acquired, what is going to happen is that in the first step, the marketplace is going to build an iSHARE Json Web Token and is going to authenticate itself in order to get an access token that will allow the marketplace to access to the authorization registry of the data owner. Okay. Then the marketplace is going to create a new policy or a new delegation evidence. It's going to use the metadata that has been provided of the product, and is going to use also the identity of the buyer organization, that is the participant organization of the user who has bought the offer. When we have this policy, the marketplace is going to use the token that we have get in the first step and this policy, and what we are going to do is to submit the new policy into the authorization registry of the data owner. With that in place, the organization that has bought the data will be able to authorize their users to access to this data, and when they are going to access to the data, the proxy or the security framework, as we saw on Tuesday, the security framework is going to check whether the user can access to the data or not. And if the organization has bought the access to the data, he's going to get the data. Okay, and that would be all because I'm not very good for making the live demo right now. So I think that the next speaker will be Stefan, that is going to show you how all these pieces that has been presented are going to fit together.
Okay, so hello, and let me share my screen. Okay. So yeah, my name is Stefan Wiedemann. I work as a technical lead and architect at the FIWARE Foundation, and I will now show you how to bring all the pieces together in let's say, demonstration application. You will see there will be some duplications to before, but I think it will help to understand the whole process. What can you expect here? We will have an overview about the example, then the prerequisites. Then we will go to the actual demonstration. And after that, I will discuss what happens in the background. And in the last step, I will tell you how to set up such a system on Kubernetes. Okay, the example itself. What will we showcase here? The example will be about the delegating data service access rights within a trusted data space, as this whole stuff is about. We will delegate from an organizational level down up to a user level, and we will show that the service provider does not need any knowledge about the user which finally accesses the service. In our system, we will have a couple of different parties. One is the packet delivery company, which offers a delivery order service on the i4Trust marketplace. The delivery order service allows customers to see and also manipulate the
orders or the delivery that they are running inside there, or that they have currently ongoing. We have different retailers in our system, in our example use case. Mostly the two parties are, or in our example, they are shops. We have the No Cheaper Incorporated and we have Happy Pets Incorporated. And we also have the trusted authority, which ensures the trust among our organizations. That's what was described as the iSHARE satellite before. What steps we show? We will create the offering on the marketplace from packet delivery. Then the offer will be acquired by the shops so that they can offer the packet delivery service to their customers. And then we show how a customer of the different shops does actually access its delivery orders. Okay, now go into more detail. What does the packet delivery company do on the i4Trust Marketplace? As said, it provides a digital service about packet delivery orders. A delivery order itself is mapped to a digital twin entity that is characterized by different attributes, mostly the issuer and the destination, and also the planned date of arrival and planned time of arrival. Especially those two are important in our use case here, because this is where we will have the option that our customer can basically change the time he wants his packet delivered. The packet delivery company will offer two kinds of services. One is as simple as the standard service, where a customer can simply read the current status of its packet delivery. This maps basically to a simple HTTP GET. That means packet delivery in the end is offering a service where someone can access via HTTP GET the digital twin on its API. And it will also offer a gold service. This will also allow to change certain attributes on a delivery. In our case, this will planned time of arrival and planned date of arrival. That means we also will allow patch requests to the packet deliveries API. Then what will the shops do? The Happy Pets Incorporated is a shop that offers premium products for pet owners. And the Happy Pets will acquire the premium service from the packet delivery company that is offered on a marketplace, so that it can offer the gold service to its customers, but also the standard service. So basically the standard service is included in the gold service of the packet delivery company. The No Cheaper Incorporated is a shop of bargain clothes that sells them at big discounts. And they will acquire the basic service on the marketplace, and so that they can only offer the standard service to their customers. The customers itself are obviously customers of the shops itself. They are human, so we will see mostly human-to-machine interaction as described in Rajiv's part. What happens is that after the checkout at the shop, the delivery order at packet delivery is created. So if a customer buys something in the shop and then checks out its purchase, then the delivery will be created at packet delivery. And after that, the customer might want to view and or change when its packet gets delivered. So he accesses the packet delivery portal and then can see the time of arrival, or in case of a Happy Pets customer, can also change it. Okay, what prerequisites do we have to basically play through the whole demonstration? On an architecture level, we need the marketplace, which is the business API ecosystem as described by Francisco. We will have the Happy Pets Incorporated and No Cheaper that both have a very similar setup. They have their identity providers. In this case, it's always two identity providers, one for the company and one for the customer. They have an Authorization Registry, and they also have a shop system application. At packet delivery, we also have an identity provider, which in this case is mostly for the employees. We have the context broker that is storing the digital twins of the deliveries. We also have a PEP proxy with a policy decision point, where the requests to the packet delivery API get intercepted and handled. And we have the Authorization Registry, and in this case, an activation service, which I will describe a little more in detail later. And we have the portal application where the customer can actually see the delivery itself. And the trust authority is, as already mentioned, the iSHARE satellite. Okay, a little more in depth. What is the marketplace built of? The marketplace uses different databases, mostly MongoDB and MySQL, to store all the entities that can be created and retrieved through the APIs. As Francisco already mentioned, the TM Forum API adds a reference implementation of the TM Forum APIs, and it consists of multiple components. One is the charging backend that is taking care of rating, charging, and billing. Then we have the revenue sharing service, which enables the revenue sharing feature that was described, and also the so-called logic proxy, which serves for the UI portal authentication and also does the whole API orchestration. That's basically all for the marketplace. What prerequisites do we have for the trust authority? As mentioned, the trust authority is installed per data space. It uses the iSHARE satellite, so every data space has its iSHARE satellite in this case, and all the participating organizations have to be registered as a trusted participant there. So we have the marketplace, the packet delivery company, the Happy Pets shop, the No Cheaper shop, and also the iSHARE satellite registered at the trust authority. What additional requirements do we have at Happy Pets? As said, Happy Pets has basically two identity providers, and we already have users there registered. In the company IDP, we have an employee registered, and we also have a customer IDP where we have a standard customer and a gold customer already registered. We have an authorization registry where we use the iSHARE test instance. So it's basically not directly deployed into our system. We are using the already running one at iSHARE testnet. And in this example, we did not implement the whole shop system. So we more or less skipped that for simplicity. In the following, we assume that the customers are already registered, as mentioned, that there are already existing delivery orders for the customer, and that the policies for the customers are already assigned from the Happy Pets shop. That means that Happy Pets already has issued this policy for its customer. You can see we have the policy issue Happy Pets, then access subject is the ID of the concrete user as it's set in the IDP. And we also have a policy that describes the whole the capabilities of the user itself. That means he can access a resource of type delivery order. The resource that it can access has the ID of its delivery order, and he can access and patch the attributes planned time of arrival and planned date of arrival. We have basically the exact same setup for No Cheaper. I will not describe every of the details, but one difference is No Cheaper only will offer the standard service to its customers. Therefore, the policy looks a little different. We again have the policy issuer, which in this case is No Cheaper. And we have the access subject, which is again the ID of the user. But the policy itself is different because it only allows the action get, which means we can only read the delivery order, but not change any attributes of it. We have more prerequisites at packetdelivery.com. We have the demo application for the portal deployed. We also have an employee user registered there already. And we have the context broker deployed as the service provider itself, which provides the NGS ID API for reading and changing delivery orders. And we also already created an initial delivery This is the example for the Happy Pets delivery. We also have deliveries for Node Cheaper already created, because as said, we skipped the shop part, so we already have the delivery available. What more do we have at the packet delivery? We have a PEP proxy PDP deployed, as mentioned. In this case, we are using Kong, which is API gateway, which is relatively big in the market currently. And we have the context broker as an API backend configured there, with the attribute-based authorization based on iSHARE policies. We're using declarative configuration mode here. There are also front ends available, but we don't really need them for our use case in this here. We have, again, an authorization registry instance, which shows the access policies of the organization. We, again, use here the iSHARE test instance. And we have the activation service, which is basically part of the demo application and is required for enabling the marketplace to create the policies at the authorization registry of packet delivery. The marketplace needs an initial policy already, because it also needs to be allowed to actually create the new policies inside the authorization registry of packet delivery. So we see here the policy. We have packet delivery is issuing the policy to marketplace, and it is allowed to post delegation evidences on the marketplace. Okay, now I will switch my screen to go to the actual demonstration. As said, we will start with creating an offer, then acquire access to the offer, and also access the service itself. So first of all, we have to go to the i4Trust Marketplace, which is a demo installation running in our system. And since we want to create an offer as packet delivery, we have to click the sign in button and change the ID and choose the IDP of packet delivery.corporated. And then as packet delivery, we can sign in. We are using an employee of packet delivery. We are here at the packet delivery's IDP, which is an instance of Keyrock. And we can sign in and get redirected to the marketplace. On the marketplace, we first would have to create a catalog. We already have a catalog available for packet delivery company, which is active and launched, but currently does not have any offerings. So as Francisco described, we first have to create a product specification, so that a customer can buy, so that we can create an offer based on the product specification. After that, I will click on new, and we will start with creating the premium service. Every of the product specifications needs a name. We can enter the brand here, which is packet delivery. Then we can go the next step. This is not a bundle of products, so we only offer one service, so we don't have to enable anything here. But it is a digital product. The digital asset type is NGSI LD data service, because we are offering access to the context broker API. We need to tell the marketplace where this API is available. So this is this. You can see that this goes through the Kong endpoint that we want to offer as the packet delivery service. The media type is NGSI LD. And we need also need to tell the marketplace which authorization registry it should use. This is the URI of the iShare.testnet authorization registry. And we give the endpoint that it can be reached here. We set the duration to be active for this, so that the offer, that the policy will not run forever, which is mostly important for our demonstration use cases. And then we can define for which types the service is created here. We want it for delivery order. because we are offering the packet delivery service, and we want to enable access on all gets, get access on all attributes, and we want to allow them to patch the blend time of arrival and blend date of arrival. This in the end is the whole definition of our data service. So we can go to the next step. We have the option to add additional characteristics, which we don't need, but we can include a nice little picture for our service here so that we can see it nicely on the marketplace. We don't have any relationships here, so we can click to finish. And our product specification is active now. We also need to launch it so that it's available for our customers or for creating offers. We want to create another product specification because we also want to offer the basic service, which is only get and not updating. So in the end, we have the exact same workflow. We create the name for the product. We enter the brand. We again have not a bundle of products, but a digital product. So for these parts, this is basically all the same. We again have the same Authorization Registry. And we also restrict the duration of this whole thing. We want delivery order, but this time we only want to allow get, but not patch. So someone who acquires the service is only allowed to do the delivery order, but not to update the attributes. We again have no characteristics. We can upload another picture here. We don't have relationships. So we again can finish this one and launch it. Okay, now that we have the product specifications, we can create the concrete offers, which means the thing that our customer then can acquire. We start again with a very similar interface. We create the name of the offering, which would be the packet delivery premium service, and we add a description so that anyone knows what this is about. It's again a bundle of offerings, but we can now select the specification that we created. We want to create a premium service, so we select the premium service here. We select in which catalog it should be. It obviously should be in our catalog. We don't have a category to edit. We can choose a license here for data. We don't really need it in our example. We can also define SLAs for the service offerings. But in this case, we also want to create a price plan. We want a price plan where the customer does pay every month. So we call it monthly payment. It will be recurrent for every month. And we say it goes 500 euros. We create this one and now have the price plan at our offering. We set the next, and we can define, we can select a revenue sharing model as explained by Francisco. And then in the end, we can take a look if everything works and is as we wanted, and then actually create the offering. Now it's also active so that someone can buy it. We also have to launch it. And we also have the exact same flow for the basic service. We have basic service. We create a description, a bundle. We select the basic service as a specification. We select the same catalog. We skip category, license, and SLAs. And we don't want this to be basically open for anyone, but we also don't basically want to buy it, that it can be bought. So it doesn't cost anything. So we don't say it's an open offering, but we also don't create a price plan. Revenue sharing can be also again selected, and then we create the service. We again set it to launched so that it can be found in the marketplace. Now we will switch to the perspective of Happy Pets. First, I want to show you that the Happy Pets customer itself can log into the Happy Pets into the packet delivery portal, which is our example application, but is not allowed currently to basically see any of its deliveries. So we log into Happy Pets as a customer of Happy Pets, which is called Max Customer in this case, and is forwarded to our packet delivery portal. He can now select his delivery here and see if we can click it and see if something is possible. But no, he has a policy already created so that Happy Pets is delegating to the customer, but Happy Pets itself doesn't have already the permission or the policy to access the delivery portal. So we now switch to the perspective of an employee of Happy Pets. So we select the Happy Pets IDP instead of the packet delivery before. Sign in as the employee of Happy Pets into the marketplace. And then we go to the catalog of packet delivery, and we decide to buy the packet delivery premium service. So we added our cart. We can go through all of this. We have to read the terms and conditions. We can look into the price plan. Okay, it costs 500 euros a month, and we add it to the cart. Since the basic service is already included in the premium service, we don't select it specifically. Now, since we bought everything, we go to the checkout. We can again see everything, and then we go to checkout. And now we also have to buy. The system that we are running here is integrated with the PayPal sandbox, so we can do the payment flow. You can see here our price. And now the payment was accepted. We can go back to this, say payment completed, and we bought the premium service. So now we can log out again here, and we can see if our customer is now allowed to actually access his packets. We logged in as the customer, and we go to the delivery order. And actually we see that he's now allowed to get the information about its delivery order from the packet delivery company. Since we have the premium service, our customer also should be allowed to change the planned time of arrival. Let's say he wants to have it an hour later, and probably this year. He can change it and gets the packet delivered tomorrow. Okay, so now we see that with the premium service, the customer is allowed to do this. Now we will also buy the service from NoCheaper, because they also want to allow their customers to at least see where the delivery is. So we sign in with the IDP of the packet of the NoCheaper corporation as an employee of NoCheaper. But instead of buying the expensive premium service, we only buy the base service. Since this one doesn't cost anything, we don't have to do the whole payment process here. We will also do the checkout. And now we have the basic service bought for the packet delivery for NoCheaper. We log out again. And now we can log in as a customer of NoCheaper in the IDP of NoCheaper. And we can open the delivery order of the NoCheaper customer. We go to get delivery order. We can see that we now can see the delivery and its time of arrival. But if we try to change the time, we should get rejected because our service does not allow this. So this interface is not very nice, but as I said, it's only a demonstration application. And I think makes pretty clear what actually happens in the background. Okay, that was basically the whole demonstration. Now we will take a look on what actually happened in the background when I clicked all those buttons. Okay, what happened when we create an offer? Okay, the employee of Happy Pets did request the login on the marketplace. So we did go to the marketplace website, and we selected to log in with our own IDP. So marketplace redirects to our IDP at packetdelivery.com. The identity provider of packet delivery then has to validate the marketplace as a trusted participant at the trust authority, and the employee performs a login based on the OpenID Connect standard. And after this, it's forwarded again to the packet delivery portal. When he was logged in, we created the offer for the standard and the premium service, which means we create the specification and all the data model as you have seen, which is then stored at the marketplace. That's basically all that happens when the offer was created. The more interesting part is what happens when the shop is actually acquiring the access rights and activating the service. So as an employee of Happy Pets, we more or less used the same login process. So we went to the marketplace portal and were redirected to our own identity provider. Again, the identity provider validates that the marketplace is a trusted participant and then forwards to the marketplace again with the JWT token. There, the employee selects the premium service and performs the checkout process, including the payment. When this is done, the marketplace itself requests the packet delivery's authorization registry, as we configured in the creation of the offer, to create a new policy for Happy Pets to allow the premium service there. In this case, the authorization registry also has to validate that the marketplace is a trusted party and creates the policy inside its own authorization registry, so that Happy Pets is able to delegate the premium services to its customers. And as we already mentioned, Happy Pets itself has also to grant the policy to its customers, so that we have in the end two policies: one from Packet Delivery cooperated to Happy Pets, and one from Happy Pets to the Happy Pets customer. We can see the policy that was created by acquiring the offer here. As mentioned, type delivery order, it has the attributes that we're allowed to change: planned time of arrival and planned date of arrival, and we're allowed to do patch and get on those things. In reality, actually, this policy would be split into two, because with the current setup, it would be only allowed to get those two attributes, but the full policy would have been too big for this slide. Okay, the acquisition from NoCheaper is more or less the same, so the flow itself is going exactly the same, but the policy that is created is not as, let's say, powerful as the one from Happy Pets was. That means packet delivery does allow NoCheaper to get on delivery orders, but no patch is allowed. Okay, then what's happening when we're actually accessing the service as a user? So as we logged into the portal of packet delivery as a customer of Happy Pets. So very much the same as we already seen with the marketplace. The Happy Pets customer goes to the portal and selects that he wants to use the IDP of Happy Pets because he's a Happy Pets customer. So the portal forwards him or redirects him to the identity provider of Happy Pets. The identity provider again has to validate that the packet delivery company in this case is a trusted participant, and then redirects with a JWT token back to the portal. After the login is performed, the customer has a JWT token that can be used at the portal. The JWT token can be used by the packet delivery company to actually get the registered policies from the Authorization Registry, but there's also the possibility to already include all the policies into the JWT token. When the customer now presents this token to the portal, he can see the details of its delivery order. How that actually happens is something I will show in the next screen a little more in detail, because the flow is the same for changing the data in the portal. In this case, as a customer, we are already logged into the portal. And now we send the request to change the planned time of arrival to the portal. This request is intercepted by the PEP proxy policy decision point, which first has to validate the JWT token, which means it checks the signature so that it only works with a token that is actually valid. Then the proxy requests the policies that are assigned to the customer and from the Authorization Registry, or it takes it from the JWT token, depending on how it's done. And then it checks if the customer itself that was mentioned in the JWT token is allowed to access the service. So it basically checks the policy that HappyPets has to create for its customers. If this policy is valid and available, the proxy also checks if HappyPets is allowed to actually delegate this policy to packet delivery, which means it checks the second policy that was created when HappyPets bought the service at the marketplace. And if both of the policies are valid and available for the customer, the request is forwarded to the context broker and the actual data is changed. We can see the two policies that I talked about here. That means we're checking the policy that HappyPets created for its customer. The issue here is HappyPets, with the subject that is the user ID of the customer. And we have the packet delivery to HappyPets, which has the policy is issued by packet delivery, and it allows HappyPets to access the data. We have in the end the scenario for no cheaper is more or less exactly the same, only that the policy is a little different. We again check that both policies are present for our user, in this case no cheaper to the customer with only the allowance of get, and also that the packet delivery allows no cheaper to get this data with the other policy. As we have seen, if the user now wants to change the data, the PEP proxy will decide that no such policy exists and reject the request. Another scenario that we did not show here is the machine-to-machine interaction. The previous use case showcased mostly human-to-machine when the end user was accessing the service, but the framework also supports machine-to-machine interaction. Those implementations are part of the upcoming releases of Keywalk and the Kong plugin. A possible use case for this would be the creation of the delivery order from the shop system to the packet delivery company. This is the part that we skipped in our system, so we assumed that it already exists. But when a customer orders a product, the delivery order can be automatically created as soon as the product is ready for pickup. So the shop system itself can contact the PEP proxy. This would require an additional offering from the packet delivery company at the marketplace, so that the HappyPets, for example, can acquire the service and then can use the policy that allows posts on type delivery order to the API of packet delivery. We have it more deeply described here, but the flow is again very similar to the flow that we have in our human-to-machine interaction here. The shop system directly contacts the identity provider of packet delivery com. Packet delivery checks the validity of the token that the shop system sent and gets back a signed JWT token. This token then can be used to access the PEP proxy, where the proxy itself validates the policies that were created for, the one policy that were created for Happy Pets, and left at the Authorization Registry, and then allows the request to pass through to the context broker. We can see more details here. So the token itself will be a JWT token, a JWT Bureau token with the scope iSHARE that is issued to the token endpoint of the identity provider. The identity provider then will return a signed JWT token that is issued from packet delivery company to Happy Pets itself. And we also have the mentioned policy that gets validated by the PEP proxy from the Authorization Registry when it gets this request with this token. In this case, packet delivery allows Happy Pets to create delivery orders. Okay, now how does the setup of those components look? We are deploying all our software, in this case, to Kubernetes. So we provide a set of Helm charts. All the configurations and charts are available in our GitHub repositories and also as part of the i4Trust tutorials. For the marketplace, we need essentially four Helm charts, one for MongoDB, one for MySQL, one for Elasticsearch. Those three are provided by basically third parties, open source providers. And then there is the business API ecosystem Helm chart that is provided as part of FIWARE's Helm repository. All those charts needs to get sufficient configuration parameters when it's deployed with Helm. We provide a set of those default values in our GitHub repository under i4Trust tutorials. Then we have to deploy actually several identity providers, several instances of KeyRock. As described, we have two of them for NoCheaper, we have two for Happy Pets, and we have another one for the packet delivery company. The Helm chart for KeyRock is also available in the FIWARE Helm charts repository, and the KeyRock itself needs a MySQL database. In our example, we use one MySQL instance with different databases. In a practical environment, those will definitely be different because every of the participants will definitely have its own database, maybe even more. Then we need the service provider. In this case, it's a FIWARE context broker. We are using Orion LD here, which is a component from the FIWARE catalog, and which is also available as a Helm chart. The context broker that we are using here only requires a MongoDB database. We're using the same that we deployed in the first step here, but again, in a real production environment, this will definitely be not the same as we're using for the business API ecosystem. And then we also have the deployment of the PEP PDP. In this case, we are using Kong. Kong is available also with an official Helm chart from the producers of Kong. But we are configuring Kong with plugins that we create in FIWARE to actually support the iSHARE functionality. And there are, in the end, two options to deploy them. You either can use the Kong that you already have somewhere and deploy the plugins itself, or you can use the image that we produce for Kong ourselves, which is based on the official Kong plugin, Kong image, but with the required plugins already pre-installed. As mentioned, we then do a declarative configuration of the policy enforcement. Kong uses a YAML file for this that can be provided on startup, and in the end it looks like this. So we define the Orion endpoint that should be secured. So this is the address of Orion inside our Kubernetes cluster. It's a service name by the Kubernetes SDN. we define the port that the ORIN is available at. And then we define the route that the service actually is available on the public internet. We say we want to have a subpath of our actual Kong address, which is packet delivery in this case. If we configure that, Kong will handle all the requests to Kong/packet delivery with this definition. For this route, we define that two plugins should be used. One is the NGSI iSHARE policies plugin that we configure to handle the header, the authorization header. So we accept bearer tokens provided in the authorization header. Then we configure the authorization registry that our system should use. We configure the satellite that it should use. And we also configure the identifier that our system uses itself. So to contact all of this, the Kong also needs to be able to present its identity. And since it's the PP of the packet delivery company, it also has to provide the ERI of packet delivery. And as a last step, we also use a plugin that overrides the authorization header before it forwards the request to the actual service endpoint, because in this case, ORIN does not need to know about it and maybe gets confused if it gets it presented. Then what else do we have? We have the two components that we only use for our example application, which in this case is the portal application that you have seen, where you can acquire, where you can look into the delivery, and also the activation service that gets contacted by the marketplace to actually create the policy inside our authorization registry. And as a last step, we also have the authorization registries and the scheme owner or trust authority in the system. In all our examples, we now use the authorization registry and also the iSHARE satellite at iSHARE testnet. They are publicly available, and you can contact iSHARE to get registered at the test instances and retrieve test certificates so that you can also use them. But they are also available. The satellite is also available as a deployment guide on GitHub. And there are authorization other options for the authorization registry, like Keyrock itself implements this functionality, and it can be activated. It's closer described in the configuration manual, or you can use the reference implementation of the authorization registry at the iSHARE GitHub account. All deployment instructions are provided in our tutorials repositories, and also in another GitHub repository which focuses more on the production installation. We're basically constantly working on those and currently improving them further to make them more production ready and more stable to deploy. And as a last interesting link, we also have a whole section about data spaces in the FIWARE catalog, where you also can find all components related to that. Okay, thank you. That was now my part. I hope it helps a little when you start with your experiments. And I think we're now open for questions. Are there any questions?
Yes. Are there any questions from anyone, or is it all clear what we explained? Well, there was one question about the presentation link, which I already answered, but I'll re-emphasize. All our training sessions and the slide decks, we always publish them. So do subscribe to the YouTube channel of i4Trust. Then you will see the videos when they are published. And from our website, you can find the links to the slides. Also on our GitHub, by the way, we have a training repository where we publish all the slides we use for all the training sessions. So there as well, you can find these presentations. Yes. Okay. Any questions from anyone? If not, then I would wish you all a very nice weekend. I hope you really enjoyed this training camp, and uh, well, we look forward to some of you being certified as LEPDS from the DIHS specifically, and of course, looking forward for participation in the second open call, which is ongoing. And see you on the i4Trust community. Feel free to reach out to us in case of any questions, or that would be closing remarks from my end. Thank you.